All right, let's reconvene. Is anybody wondering what this thing is? On my, you guys are wondering, is anyone like been looking at that going like, what the heck is that thing? What is it? Well, let me tell you. So this is what did you say? It looks like a potato. That's got to be coincidence. That's got to be coincidence. So this is the packet potato. This is the worst packet analyzer ever by design. So it does two things. I don't know if you can see because of the lights, but basically it does two things. It listens for a packet, and when it hears a Wi-Fi packet, it checks to see whether it is an OFDM data rate, like 6, 9, 12, 18, 24, right? One of those data rates, or a DSSS data rate. That's a data rate of 1 or 2 or 5.5 or 11 megabits per second. If it's an OFDM rate, it blinks all the LEDs in the OFDM shape. If it's a DSSS rate, it blinks all the LEDs in the DSSS shape. And that's it. That's what it does. So, thank you. Thank you. Yeah. So, I did probably like 90% of the code for it. Had a little bit of help from my brother and a little bit of help from just today, actually. Just barely got this thing working. A little bit of help from Ryan Woodings at MetaGeek. My brother did the PCB design for me. I basically gave him a sketch and said, hey, this is what I want, and he came back with this. And there's a little fry on the back. He says, not sure if spectrum analyzer or packet analyzer because it's kind of ambiguous. So anyway, just for fun, and the goal is that maybe at some point you can get a little kit, maybe buy a little kit or something. I don't really want to make money on it. I just want to have fun. Where you can buy this and solder a bunch of parts to a PCB and have your own packet potato, and you could wear it at a conference as a badge or whatever. So anyway, that's what that is. So let's go ahead and move on. Oh yeah, question? What's that? The number. Yes, that is the current channel. So right now it's on channel 1. Now we're on channel 13, and if we go down to channel 6, it's kind of headache-inducing because there's a lot going on in channel 6 right now. So yeah, that is the packet potato. I'm going to pull out my cheat sheet really quick here to introduce our very next guest. I'm going to bring up Gustavo. He is a network engineer at Apex Technology. He's CWNE number 225, a CWNT, and part of the CWNE Board of Advisors. Gustavo, come on up.
All right. Good afternoon, everyone. So what we're going to talk about here is troubleshooting roaming issues in an all-wireless office environment, okay? So let's start. I'm going to talk a little bit about me. So my name is Gustavo Mastroianni. My Twitter handle is @GugaMastroianni. I'm originally from Brazil. I'm 33 years old. I'm a husband, and I'm a father as well. I'm a network engineer at Apex Technology Management. I'm based in Redding, California. I have a bachelor's degree in electrical engineering and an MBA in IT. I'm CWNE 225, and also a CWNT for CWNA, CWSP, DP, and AP. I'm a member of the CWNE Board of Advisors. This is my 3rd year. I'm also a member of the WLAN Association and a co-founder of the Mobility Brazil community. So let me give you a brief overview of what I'm going to talk about here. So this is the project summary of the project that I worked for one of our clients in Reading. And the idea was to do a rip and replace of its infrastructure. So this is the whole area of our client. So its line of business is to rent heavy machineries to other companies. Okay, so the key things for this project was replace all wired workstations by wireless thin clients, which was a total of 31 thin clients. New network infrastructure, so it was a rip and replace. We take it off everything, put it on new things. So it was a firewall. PoE plus switch is either stackable or non-stackable. Wireless LAN infrastructure. So since everything was going to run over wireless, we needed to make sure to provide a reliable and also a very fast and also redundancy on the wireless LAN infrastructure side. So that's why we put it on 1+1 redundancy. A server where all of the thin clients would connect it to, and brand new Cat6 cabling for every single thing. Either outdoor rating, where we would also connect the outdoor access points, or indoor rating. So what were my customers' requirements? So remember, every time that you design a project, the first thing that you do is gather all of the customer requirements, because with that, you will be able to design and, in the end, provide all of the things that it needs to meet those requirements. So the first one, provide Wi-Fi in a 6 acres area. In other words, full coverage from one side to the other, east to west, north to south. Also, support Wi-Fi calling. Why? Because on the area that they were in, they were right under the antenna, so they were getting like the shadow of the cell phone coverage, so they were not able to use 4G as you would use in a regular cell phone coverage area. Also, for the outdoor areas, they only needed coverage and seamless roaming. But for the indoor areas, which all of the thin clients would be on, they would also need capacity, coverage, and seamless roaming. And for that, we would divide that in 3 SSIDs. Right? We would divide the wireless LAN infrastructure in 3 SSIDs. The first one, would be a 5 gigahertz only for thin clients and no roaming requirements. So we chose WPA2 personal. For the smartphones, it would also be a 5 gigahertz only SSID, but we would need roaming. Roaming would be required using WPA2 personal, and if it's possible, use fast transition as well, because it was desired. So since it's a mobile device. And for the gas, we would only provide 2.4 gigahertz band SSID for them, roaming required as well, and WPA2 personal. So after gathering all their requirements, I went ahead and designed it, deployed it, and as you should do it, post-validate your deployment. On that post-validating phase, I was able to meet the coverage requirement. I was able to meet the capacity requirement, but I was running into issues where seamless roaming was not happening for the smartphones. Remember, thin clients, they are just mobile. They are going to stay where they are, and that's it. So most of the things that I was working on was related to smartphones. So, because of that, let's go to the first issue that I was having. The smartphone SSID, it was using fast transition pre-shared key, and I was having reassociation failure. So whenever I was roaming from one AP to another AP, it was not roaming properly. It was disconnecting and not connecting and reconnecting to the SSID again. So here's the first packet capture. So if you see right here, that's when I was getting the deauthentication frame and associating, going through the process of authenticating, associating, and exchange the 4-way handshake, and then back again to the network. So if you see right here, that's the deauth right before I was on channel 36, and then I moved to channel 40. So what was the smartphone that I was having issue? It was a Kyocera DuraForce Pro. Why they were using this specific smartphone? It was because those cell phones, they are ruggedized, so they were using for the field guys where they would take pictures of the heavy machineries and uploading to a point-of-sale application on the internet, and that's why they needed roaming, where those field guys would go from one heavy machinery to another heavy machinery, taking pictures, checking if the heavy machineries were okay right after they were back from rental. So, but why this specific smartphone was not able to roam properly? So, before I deploy it, and when I was designing it, I checked all of their devices, and one of the things that I saw on the datasheet of the Kyocera DuraForce Pro was they supported 802.11r. It's right here. But why it was not roaming? Even though they said it supported. What I did to overcome this was, so before that, here is the deauthentication frame. So you can see right here, it was the Kyocera, right? And the deauthentication reason code is reason 3. Deauthenticated because sending station is leaving. So what I said, well, if it's not working with fast transition, pre-shared key, let's just try and see if it works with the regular pre-shared key without using fast transition. So I removed the configuration for the fast transition, and in fact, I was able to do the reassociation process flowing normally. So, since those smartphones were not being used for voice over wireless LAN type of deployment, and only connectivity was required within the whole coverage area, customer requirements, check, right? Now, even though I was able to fix or do a workaround which would still meet my customer requirements, I went ahead and started to check the other devices, which was the smartphones that were used by the admin staff, those guys that worked within the office. And those phones were Samsung smartphones. But they still were not able to roam properly, even though I downgraded the smartphone's SSID from fast transition PSK to PSK. So since it's now WPA2 PSK, after my first troubleshooting, what's going on? So this is the RSN information field of the beacon frame of the SSID. So you can see right there that it is PSK, it is using AES, and managing frame protection, it is not mandatory. So let's check the reassociation request frame, because the issue was still I was not able to roam properly from one AP to another AP. So here's the reassociation, the RSN information from our reassociation request frame. Okay, so we have the pre-shared key. It is a PSK. We are still using AES. MFP is, as it is saying that it's not mandatory, but check it out. Group management cipher suite. And I'm getting, in this, it is basically saying that I'm using management protected frames or management frame protection, 802.11w. But why I would be using that if it's not something that I was set that it was set before and it's saying it is not mandatory? Why? So let's check the reassociation response frame coming from the AP. What it was saying. It was saying that status code 45, invalid RSN information, client capabilities. So something was going on in regards of the RSN information when I was roaming from one AP to another AP. But what? So my line of troubleshooting was, so I have the information from the reassociation process, from the reassociation frames, either the request and the response. So let's check what's going on when it first associates to the AP. It's still the same thing. So we are getting pre-shared key, AES, and right here, not mandatory, even though on the above field it says if it's capable and it's enabled. So what I started doing, I researched it on Google, trying to see if someone else was running into the same issue that I was running. And of course, if I'm not able to solve the issue, I'm going to try to talk to someone that might know the issue, right? So I went ahead and opened a support case with the tech support. In the end, it was a bug. So the vendor confirmed that it was a bug. So everyone, most of the people will be familiar with this. So here's the bug. 802.11 client association data traffic drops after 802.11 are roaming with PMF enabled or optional. Even though in my case, as you could see, it was a pre-shared key, and it's not like in the headline of this bug code, it was still giving me headaches about this. So it says here what the symptom. 11W client association data traffic drops after 11R roaming with PMF enabled or optional. So what is the workaround? Disable PMF. Do not leave as optional or mandatory. So at that moment, I was able to just disable PMF, and if I'm not wrong, a few weeks later, they released a new code that was fixed, and I was able to upgrade it and do it, and at least I'm not gonna be able to hit that code again. Okay. So as you can see, post-validation is very important for every design and every deployment that you do. After that, everything went fine. I was just checking around the configuration on the wireless LAN controller. And what I'm going to show you now, it's going to be a bonus. It's not related to roaming, but it's going to be a bonus because I want to see if everyone here is aware of what was happening with my thin clients. So I was checking the message logs on the wireless LAN controller, and I was getting some errors saying, hey, there are some clients that are missing supported data rates. So if you check, I know it's not too great, the MAC addresses, it's very small MAC addresses, as you can see right there, but you see that the first 6 characters, they're pretty much the same. So it means that it's all coming from the thin clients. Remember, as I said at first, thin clients SSID is 5 gigahertz only. So what's going on? Let's check the association request for a random thin client. If you guys are able to see it, can anybody tell me What's wrong with that? One hint. Yep, that's correct. So why DSSS and DSSS data rates are doing on the 5 gigahertz band? That's why the wireless LAN controller was complaining about it, saying, hey, I do not support that data rate on this specific SSAD. So just a few information about the wireless clients. So they were either Intel Wireless AC 9560 2x2 Wi-Fi cards or Intel Wireless AC 7265 2x2 clients. Since they were thin clients, we would not be able to update it using Intel's drivers that they provide on their website. So we would only be able to get the drivers coming from Dell, and it was not a specific driver. It was like the whole bundle where you would update the drivers for all of the for the Wi-Fi card, for the whatever they are running inside of the thin clients. But I never got a feedback from them. So it's still there. It is complaining. It's still complaining that it does not support those data rates, but it's working, and it's not something that it will bother or will degrade their Wi-Fi experience. So, but it's still there. Now, what are the takeaways here for this presentation? And I want to make sure that you guys can get this. First of all, always meet your customer requirements. Always, always, always. Make sure that you gather them at the beginning of the project and explain to them what are the pros and cons of their requirements, and tell them that it's going to cost money to implement them if their requirements are too high, if they are low, or if they're in an average. Just make sure that you can meet those expectations, and you are able to meet those expectations and lay it out everything you can. Second thing is check the specifications of the devices. So as you could see, even though I pre-checked and I read the data sheets for every single device that they had, one of them was not meeting the requirements that they were saying that they could meet. So just double check, and because of that, you can trust, but verify. If I didn't verify that, they would only just roam from one AP to another, and they would be disassociating from one AP and associating back again to the other AP. So you can trust them, but verify. And last but not least, post-validate your deployment. If I did not post-validated my deployment, which was my design, my deployment, I would be receiving complaints from my customer up until today. So make sure that you do all of those things whenever you're designing and deploying a project of yours. Any questions? Joel? Hold on, let's see if we can get a microphone, so because it's recording. Back there. Right in the corner.
So my question was really around the clients. I've seen over the years that companies will cut costs in any way they can. Were those particular clients, were they one of the cheapest ones you can buy, or were these, not the cheapest thing?
Are you talking about the thin clients or the
The thin
smartphones?
clients,
Thin clients.
the ones that had the problem with the Intel adapters.
They were, I think it was not the cheapest one, but it was not the most expensive one, and they were brand new. They were released like 3 or 4 months before we were deploying it. So maybe those that was the main issue, because they were like just released and they did not have a lot of information, a lot of feedback from the field to them. So that's why they were like, hey, I don't know what to do. And that's why I never got a feedback in regards of the DSSS and HR DSSS data rates back to me. So it's just there, but it's not doing any harm to the wireless network. Any other questions? All right. Right here.
Is there anything you would have done different, knowing what you know now, on your design?
I would probably test I would get one of their devices and bring back to my office, because since the process that I do when I do a project, I do all of the prepping, all of the configuration prior deploying to the customer. So probably bring one of each their devices, bring back to my office and test it and see if I can do roaming, if it associates correctly, test if the wireless LAN controller would be getting those alerts saying, hey, I don't support those data rates. So that would be the only different thing that I would do in this case. Everything else, it is pretty much the same. Gather the requirements, meet the requirements, post-validate, deploy, post-validate, and see if everything works. Anyone else? All right. Okay. Thank you.